Alright, starting lesson 7.2, two variable linear systems. Okay, when you're working with a two variable linear system, you want to first get them, or each equation, in standard form. Okay, and that's what we already have here, and starting with the first example. And then you want to get the same coefficient for one of the variables, but with different signs. And that's what we have for the y's. So right away we could cancel these out. And adding everything up, I get 4x is equal to 3. Then I divide by 4, and x is equal to 3/4. All right, that was pretty easy solving for x. All right, to solve for y, simply plug it back into one of the equations. Plug it back into the first. All right, then I end up with 6/4 plus y is equal to 4. Then that's the same as 3/2. Then I'll subtract 3/2. So I have y is equal to 4 minus 3/2. I need to find a common denominator. Oops. Okay. That's 1. Multiply top and bottom by 2. So I get 8/2 minus 3/2, which is 5/2. All right, stating your answer as a point, we have 3/4 and 5/2. Done. On to the next example. Okay, I have all my equations in standard form. I need the same coefficient for one of the variables. Let's see, anything I can multiply 2 by to get 5? No. Anything I can multiply 5 by to get 2? No. Anything I can multiply 3 by to get 1? A whole number? No. Anything I can multiply 1 by to get 3? Yeah, 3. So I'll multiply top and bottom here by 3. Okay, and the signs will already be different, so I don't have to include the negative. So I have 2x plus 3y is equal to 17. Distribute, and I get 15x minus 3y is equal to 51. Cancels out. I get 17x is equal to 68. Divide by 17. Alright, cool. X is equal to 4. Alright, then all I have to do is plug the 4 into either equation for x. I'll plug it into the first. Of 3y is equal to 9, divide by 3, and y is equal to 3. Alright, so my answer is 3, 4. Done. Alright, here, let's see, I have each equation in standard form. Is there anything I can multiply 3 by to get 2? No. 2 by to get 3? No. Anything I can multiply 2 by to get 5? No. Anything I can multiply 5 by to get 2? No. So one easy approach would be to multiply the coefficients by each other. So let's see, I'm going to cancel out x. So I'll multiply this one by -2, so I have opposite signs. I'll multiply this one by 3. Okay, and then I end up with -6x minus 4y is equal to -14. And then I have 6x plus 15y is equal to 3. Alright, cancel out the x's. I get 11y equals -11. Divide by 11, and y is equal to -1. Alright, so I plugged the -1 back into any of the equations. I could plug it back into the original. So I have 3x plus 2 times -1 is equal to 7. 3x minus 2 equals 7, plus 2 3x equals 9. Divide by 3, and x is equal to 3. So my final answer is 3 comma negative 1. Make sure not to mix up the numbers. All right, let's go on to another example. All right, here the equations are already in standard form. I simply multiply the top equation by 2 to cancel out the x's. So I end up with 12x minus 10y is equal to 6. And keeping the second equation the same. All right. And now I'm going to cancel out the x's. But wait, the y's cancel out as well. I'm left with 0 on the left side. And on the right side I have 11. All right, so I'm left with an equality that is false. And if that's the case, then there is no solution to your system. And here's the symbol for no solution, like an O with a diagonal line through it. All right, let's do one more example. All right, this looks a little crazy to start with. I got all these fractions in one of the equations, but just multiply by the least common denominator, and you could get rid of all the fractions. So I'm going to do this to start off with. Least common denominator is 8. So watch what happens when I multiply it by 8. So for the first equation, I end up with 4x minus 1y is equal to negative 3. All right, no more equations. That's pretty nice. Okay, and I have the same coefficient for x, opposite signs, cool, those cancel out. The y's also cancel out. So I'm left with 0 on the left side, and on the right side I have 0 as well. So that's a true equality, true. And if that's the case, then there are infinitely many solutions. IMS for short. Done. All right, so we covered all the different types of scenarios you can confront when working with systems of equations. If you have any questions, if you need any clarification, please make sure to ask for help. Begin the assignment.